Okay, so let us see this question. For the function g defined above, k is a constant and g of -1 is 5. What is the value of g of 1? So as we did last time for f of x, like f of x is something 2x squared minus 3 and something. And then we said whatever the value of x here, f of -2, for example. So we plugged in the values there. Wherever there's x, there's -2. So 2 times -2 squared minus 3. But here it's telling you g of x. So it doesn't matter whether you put f or g or h, whatever, it is one and the same thing. So g of x equals kx cubed plus 3. And it's already telling you g of -1 is 5. So let us see g of -1, what it will become. G of -1 will be k times -1 squared, -1 cubed plus 3. And that'll be equal to -1 cubed. You know, when you're having a negative number and there's an odd power, it will always be negative. Okay, negative number with an odd power will always be negative number, and negative number with an even power will always be positive. So it'll be -k plus 3. So g of -1 is equal to -k plus 3. But it's already telling you that g of -1 is 5, right? So we can plug in the value of g of -1 as 5. Or we can put this thing equal to 5. It's one and the same thing, right? Because g of -1 is 5. So we can just uh, put this, you know, what do you say? We can just rub this g of -1 and we can put 5 there. So that's what I did. I just put it on the right side. So -k plus 3 equals 5. Is it fine till now? Is it okay?
Yes.
So we can calculate the value of k. How much will be the value of k?
I got -2.
Yeah, that's right.
Okay.
Don't care about like why is it -2? Whatever it is, we have to believe that. So so k is -2. Now, if k is -2, we got the value of that constant, right? Now the question becomes easier for us. We can plug in the value of k as -2 here, and we will see g of x is actually -2 cubed, -2x cubed plus 3. So this is the actual question in which there is no constant, like there's no k. Now we have to calculate g of 1. So g of 1, how much will that be? Can you tell me what I should write here?
-2
Mm-hmm.
parentheses 1
Mm-hmm.
cubed plus 3.
So how much will this be?
-2
-2, okay.
plus 3
So how much is that?
equals 1. C.
Right. So option C, that's the right answer. Okay. And anything else here which you were not sure about?
No, I'm good with all the rest.
Okay. So this this thing which we have already done, that is rate of change and slope. Last time I told you when I was giving the introduction about the slope, I told you at that moment that you can have, you know, the slope can be, you know, change in the y-axis divided by change in the x. That means it can be, you know, rise over run, which you already know. The slope can be rise over run, okay? And the more steeper the slope, the more steeper the line, the more will be the slope, okay? For example, when you go from left to right, I also told this thing, when you go from left to right, If you're going up, then the slope will be positive. And if you're going from left to right, but you're going down, then the slope will be negative. Okay. And there's a horizontal line, there's a ground, for example, there's no slope, there's no steepness, so slope will be zero. And if it will be, infinite mountain which you can't climb because you can't climb directly up, it is infinity. The slope is infinity, or it's not defined when you're having a vertical line which is parallel to the y-axis, right?
Mm-hmm.
And also we did the forms: standard form ax plus by equals c, and the slope intercept form y equals mx plus b. And we can have the slope point form y minus y1 equals m times x minus x1, where x1 y1 is any point on that line. So we can have any three forms here, and we should know these forms, like standard form and slope intercept form and point slope form, because we're having point and slope here. We can, we'll understand this thing by the questions. So this is the slope, which we have already a little bit, introduced. Now let us see some questions about it. Let us see question number 4.
I did these.
Or, oh, you have done. That's beautiful.
Yes.
Any confusion in these questions?
I think there was one. Hold on.
Okay.
Oh, it was number 6.
Number 6. So number 6, what is the value of A if the line that passes through A7 and 1A has a slope of -5 or 9? So it's already giving you, the points x1, y1, and x2, y2. And it's telling you that what is the value of A if the slope is -5 or 9. And we know that slope is change in the y-axis divided by the change in the x-axis. That means, y1 minus y2 divided by x1 minus x2, or y2 minus y1 divided by x2 minus x1, or rise over run. Rise over run. And rise is actually, change in the y coordinates. So we'll say y2 minus y1 divided by x2 minus x1. It is same as y1 minus y2 divided by x1 minus x2. So we can take any form. And we know that x1 is a, y1 is 7, x2 is 1, y2 is a, so we can plug in the values. So we can say slope is equal to, let us take this one, y2 minus y1 divided by x2 minus x1. And we know that slope is -5 or 9. We can plug in -5 or 9 here. -5 or 9 equals y2. How much is y2?
1. No, 7.
y2?
Oh, it's A.
Yeah, it's a minus y1. How much is y1?
7. 7.
Yes, divided by x2 minus x1 will be how much?
1 minus A.
Yes, 1 minus a, exactly. 1 minus a. So what you will do after this, when you're
Good
having the, what?
question. I said, great question.
Okay, so you tell me the great answer of this.
Oh, no,
Which,
this is where I was stuck. I got all the way here and I said, uh-oh.
when you're having the fractions on the left side and the fractions on the right side, you can cross multiply the butterfly form, which you told me last time. Okay, so we can do -5 times 1 minus a equals 9 times a minus 7. Okay,
Is it just me or does there say something on the screen?
saying something? No, nothing is on my screen.
Oh, never mind. It went away.
Okay, what was that like?
Really some. It was like a gray box saying the connection was unstable, I think.
Oh, that means it was on your side. It was not on my side.
Oh, okay.
So negative 5 times 1 minus a equals 9 times a minus 7. Is it clear, like, when to do the cross multiplication?
Mm-hmm.
Are you sure?
Yes.
So what should I write after this?
You distribute -5 minus
Yeah,
9. Mm,
negative 5, and then
it'll be 14. -14.
it's
Yeah, you
a.
can -5 minus 9. Oh!
you're
And
you're not here. You're
positive
you're in
5a.
Diwali, right? I think you're not here. You're in
Here it looks like a 9.
Yeah, it's my writing.
I can
It's
hear them. They're like chopped up. You can hear it. Can you not hear it? I hear the thump, thump, thump noise.
Uh-oh. Okay, so okay, just
Okay.
few minutes, and after that we'll stop because okay, then after this,
It's 9a and -63.
correct. So can you solve this and tell me what is the value of a?
Okay. 14.5.
14.5. Let us see. Oh, let us see the options. Oh, there's no option. We can just plug in 14.5 here, and that is the answer.
Okay.
So this was question number 6. And now we are shifting to point slope form, I think. Uh, yeah, right. And in this, we will do, there are 5 questions. We will do 1 question and others you will try. Okay.
Mhm.
Or we can do these 2 questions here. So it's telling you which of the following is the equation of the line in slope intercept form. So what is the way of writing slope intercept form?
Y equals mx plus b.
Very good. So which form is in slope intercept form?
All are. Oh no. Yeah, they are all are.
Which is one is the equation of line in slope intercept form. Yeah, they are all. Exactly. But there's no option all of the above. So what the problem there? Y equals -3 or 4x plus 1, -3 or 4x minus 1, x. Well, it's all. The question is a little bit, maybe problematic. Let us see question number 5 because they are definitely all. Can you read
Okay.
question number 5?
What is the equation of the line that passes through point 4, -1, and has slope -2?
That means there's a point and there's a slope given. So which form we will use?
Point slope form?
Very good. And point slope form is y minus y1 equals
Y2 m
m
and
times,
x and x1.
yes, x minus x1, correct. So we know that x1 is 4 and y1 is -1. So we can plug in y minus, how much we'll write y1?
-1.
That'll be positive 1, isn't it?
Positive
Negative,
1.
yeah, equals.
-2
Mm-hmm.
x
Uh-huh.
-4.
Right. Which of the following is the equation of the line that passes through 4, -1 and has slope -2? So we'll try to solve this and see which equation is that. So it'll be y plus 1 equals -2x plus 8, right?
Mm-hmm.
Or we have to combine x and y, like we have to keep x and y together because all the answers are having x and y on one side. So we
Mm-hmm.
can write y plus 2x because we can add 2x to both sides equals 8 minus 1, that is
7.
7. So which option?
D.
Right, it is D. Y plus 2x equals 7 means 2x plus y equals 7. It's one and the same thing. So this was question number 5. You will try others because they are very simple, I think.
Can you put them on the whiteboard?
Definitely I will. I
Okay.
will. And yeah, last time we also did parallel lines are having the same slopes, right?
Mm-hmm. Can you highlight the page numbers on the ones I'm supposed to do? Because then I'll get confused with all the other ones.
Okay, okay. I will just mark, with some ink there. Like
Yeah, just a way where I know which ones I'm doing.
I will just mark the star on that page.
Okay.
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 So we know that parallel lines are having the same slopes and perpendicular lines are having, what is the relationship between their slopes?
They're opposite.
They are negative reciprocals of each other, right? Okay. So let us see one question related to that. Can you read the question?
In the xy plane above, if line L is perpendicular to line T, what is A?
Okay, so we are already given that these two lines are perpendicular. And if we will calculate the slope of one line, we will be able to calculate the slope of another line. So which line is having both the points given where we can calculate the slope?
T.
Right, so what will be the slope of t?
Hold on, let me do this.
y2 minus y1 divided by x2 minus x1, right?
It's 4
That is x, right? -4 is,
over 6.
oh,
1
it's 4, 1 minus
It's 4
-3
over 6, and that is
over 6. That is 2 over
2 over
3.
3. Over 3.
Right. So what will be the slope of L?
-3 over 2.
Right. And we can again use the formula -3 over 2 is equal to y2 minus y1 divided by x2 minus x1 for L, right?
For L, you
Yeah.
mean A?
Yeah. See, for line L, for line L, we can use the same thing. -3 over 2, that is the slope, is equal to y2 minus y1 divided by x2 minus x1, right?
Wait, we're
Yeah.
trying to find the slope of y of L,
No,
but I thought we already had it.
we have already done that, but we have to calculate the point.
Okay, okay, okay.
Coordinate, right? So that's why we have to use, slope and point relationship. So slope is equal to y2 minus y1 divided by x2 minus x1. So we can take anything x1, y1 and x2, y2. Or we can take the opposites also. We can take x1, y1, a and -2.
4 minus -2, 6.
2 minus 4 is -6, right?
And then we do A minus -1.
That is a plus 1, right?
1, yeah.
Then we can do again which thing?
Cross multiply.
Yes, right. So it'll be negative 3 times a plus 1 equals 2 times negative 6. And then we can distribute it. How much will, what should I write here?
Negative 3a minus 3.
Equals,
Negative 12.
okay, how much will be a?
5. Negative 2. No, 5.
Negative 3a equals,
No, you have to add. Hold on. It'll be negative 2. No, it'll be positive 2.
are you sure? When you,
Negative 3 divided by negative 9. Oh, it's 3.
negative and negative will cancel out. It'll be a equals 9 divided by 3, or negative 9 divided by negative 3. That is equal to 3. So the value of a is 3, right?
Yes.
Okay, still, I think 5 minutes left, 7 minutes left. You might be like waiting for going down, like going
I
outside.
can't. I just need her to stop chopping like this could taking the head off. Chopping it up there. And the house smells like goat and it smells kind of disgusting now. Ugh.
Yeah, these things are like, they are there, so you have to be the part of them, maybe. So we're having two equations. I told you last time, when you're having one equation, for example, y equals mx plus b, or ax plus by plus c equal ax plus by equals c, and another is like, of the same form, we can use substitution, we can use elimination to get the answers, to get that coordinate, which is which is the coordinate of the intersection of these two lines. For example, you're having the line 2x plus 3y equals 4, and 3x plus 7y equals 8. So we can, solve these two equations by either elimination or substitution, and we will get the values of x and values of y. Those values of x and y will be that point, that coordinate, where these two lines meet. For example, in this first example, it will be this red dot here where these two lines meet. And when you will get, you will get one value of x and one value of y. But sometimes you will get the condition like 2 equals 2. At that moment, you should know, or x equals x. Whatever is on the left side, that is equal to the, on the right side. So you're not able to solve it further. So at that moment, what you will do is you will understand that these two lines are coincident, like they are exactly on each other. Right? So if they are on each other, because this line, which I'm making as a red line, this is actually not one line. These are two lines. They are on each other. So there will be infinitely many solutions, because they are cutting each other at every point. Like they are joining each other at every point. So we're not having only one solution. We're not having only one point where they meet. We're having infinite points where they meet. Correct?
Yes.
So in first case and in the second case, we are having solution, because they are joining, like they at least one solution or many solutions. So whenever you will be having solutions to the equations, we say that these two lines are consistent. Okay, when you're having solution to the two lines, we say that these two lines are consistent. And if you're not having any solution, that means if these two lines don't intersect each other, or don't join each other, or don't, coincide with each other, then these two lines are inconsistent. Like, uh, some students are okay with some others, and some are very, far from others, like they don't even want to see them. So those students who don't even want to see others, they are inconsistent with each other, right? And those who are having a type of like, okayness, so that is, they are consistent, right?
Yes.
And out of them, there are few who are like, maybe, for example, two students, they are very close to each other, they share everything, like they go to school with, together, they come together. That means they're having infinitely many solutions. So that's it. This is consistent, and they are dependent.
What does the dependent independent mean?
Yeah. um it's nothing but when you're having two lines, you know uh, coincident exactly on each other, it is as if that is only one line, right?
Mm-hmm.
It is as if that is only one line. So that is why we say that it is actually dependent, because they don't they don't have any identity of their own, they don't go of their own way, they are together, like they are together continuously. But in case
Mm-hmm.
of, in first case, the problem is that these two lines are having their own, own identity. They one is having one slope, another has some different slope, and they are going in their own direction, and they just meet at one point. That's okay for them, but they don't want to be at that point only, they just move on. So if they continuously move on, and they are having their own identities, their own y-intercepts, their own, slopes, that means they're independent. They don't depend on others. They don't depend on another line, right?
Mm-hmm.
That is why we say that these two lines, which are having only one solution, they are independent. They don't care about each other. They just meet at one point, and that's it. But those two lines which are, coincident, they're having same slopes, same y-intercept, same everything, as if they are one line, then definitely they seem to be dependent on each other, and that's why they're dependent,
Is
right?
infinite solutions consistent because it has more than one solution?
Yes. Whenever you're
Okay.
having solution, no, whenever
Like
you're having
any solution at all is
any
consistent?
solution, yes, whenever you're having any
Okay.
solution, whether one, two, or many, or infinitely many, then that is consistent.
Got it.
And if you're not having any solution, like these two lines, the third case, they are parallel to each other, they don't touch each other, they don't go there, so they don't meet at any point. So that means these two lines are inconsistent.
Got it.
Great. Because sometimes these names can create confusion in the students. But if we know the definitions of these things, then it becomes very, very easier for us to do the questions. So we were on this, and our time is nearly over. So I will mark the stars on the question paper, and you will try to do them, okay?
Okay.
And those questions will also be there, where you will have to see whether the equations are consistent or inconsistent, or infinitely many solutions, or one solution. Okay.
Mm. Okay.
So try to use your, like, thinking, when should that happen, and all these things. Okay, then we'll stop here, and we will meet on which day?
Tomorrow.
Oh yeah, tomorrow. Great. One example, just one example here. See, you're having -6 equals 5.
Mm-hmm.
These are two equations. When you solve them, you are getting -6 equals 5. That means left side is not becoming equal to the right side, which is actually definitely, it is false here. -6 is not equal to 5. Then we say these two equations are having no solution. They will be the case of like, they will be the no solution case, the third case. Okay.
Okay.
And the two equations, when you will get left side equals to the right side, whether x equals x or 5x plus 4 equals 5x plus 4, left side is exactly equal to the right side, then we say they are having infinitely many solutions because they are coincident. Okay, then we'll stop here and tomorrow we'll meet at 7.